Question 8. A block A of mass 2 kilograms and a particle B of mass 0.5 kilograms are connected by a light inextensible string inclined at 15 degrees to the horizontal. They are pulled across a horizontal surface with acceleration 1.2 meters per second squared by a force of magnitude 6 newtons applied to A, acting at 20 degrees above the horizontal as shown in the diagram. The string and the force applied to A are in the same vertical plane. Okay, then what are we having here? The contact between B and the surface is smooth, and the contact between A and the surface is rough. So that means we are going to have frictional force here. Okay, mu r. So here we are going to have mg, and A has 2 kilograms, so that will be 2g. Then there will be r here. Okay, we shall have r here. Let me try to connect this one properly. We shall have our r, normal reaction. Okay, but then I will also do some resolving of forces here. So close this one here. Then we shall have 6, then cosine of 20 newtons. And then when you open it up, it will be 6, then the sine of 20 degrees. Okay, then we shall also do something here. Now, since this is a light inextensible string, then there has to be tension in it. Okay, so this tension here acts upwards. Okay, from this object here, it's taking it up. Now what I'm going to do is to resolve this t here. Okay, so I'm going to have t, then cos of 15 degrees. Okay, then also vertically, we resolve horizontally and vertically. So I'll bring this one here. So vertically, we are going to have t, then sine of 15. Of course, here we shall have the mass of B is 0.5. So you have 0.5 g. Answer. What else do we have? Now, since this is the pulling force, okay, that means remember this one, there is something they said here, that the string and the force applied on A are in the same vertical plane. Okay, the contact between B and the surface is smooth, so we don't have any frictional force here. Now the frictional force here acting on A has to be in the opposite direction. You see that? So I will have our mu r like this here, so not here like I had done before. Okay, now let's go. So let's look at what is happening on B here. So we are looking at B. Now this one is going this side. Okay, so our system is going this way, so using F, which is equal to ma. Now the movement is here, so we shall have t, then cosine of 15. Okay, that is the force taking this one forward, then minus, of course, 0 because we don't have any opposing force here. Clear? Then is equal to the mass of B is given as 0.5, and then the acceleration of the system is given by 1.2. So that means our t then is going to be equal to 0.5 then times this one, which is actually 0.6, then divide by the cosine of 15. So meaning our t to 3 significant figures is going to be 0.6 divided by the cosine of 15. This one gives us 0.621 newtons, and that is that. Then lastly, Part B, find the coefficient of friction between A and the surface. Now, for part B here, there is something that is going to change a little bit here, okay? When we are pulling this one to go to this side, this tension, there is this tension also acting like that, okay? It is pulling this one down, okay? Because of this mass that is here, so this tension is also pulling this other side. So that means the resolving is now going to change, okay? So we are going to have something like this. I'm going to have my A here, my block A. Then we are having this tension here. So I'm going to connect it to this particle here. Then we do that. So there is this tension. Remember, this is 15 degrees. So this is the tension. Now we resolve again. So up here and also down. So when I resolve it down here, then it will be facing this side. Not so. So it will be facing this way. And then I'm going to make this one a little bit dotted. And also this one here. Now, when I resolve this one down here, I'm closing the angle. So closing is going to be cosine, but now it will be facing this side. So we shall have T cosine of 15. Do you see that? For this particle here, the tension was acting upwards, and then this T cosine was facing this other side. So you have to be very careful here. Then up here, we are going to have T, then sine. No, is it even going up? So when I open this one up here, it will be facing down, not so? So it will be facing down. We have T, then sine of 15, okay? Then I think we are also having this one here, and also down here, we are having the mg. So just like I had here, this is 2g. Then what else? There is r, then 6 sine 20. So we have r, then 6 sine of 20. And then we have this one at a certain angle of 20. So we have this like that at 20 degrees C. Then we are having 6 newtons here. And then what else? This is 6 cos 20 as the horizontal component of these 6 newtons. So 6, then cosine of 20, like that. What else do we have? I think this is B, not so? Then there is mu r. Here also, there is mu r. This force here, I've put it on B here, but it is acting on this particle here. So I can even just extend it here, okay? It is acting downwards. So it is the same thing. I can maybe shift this one around here. So what I'm going to do, let me first put it here, then take this one up here like this, okay? Then this one here, we take it down like that. You see that? So meaning the forces that are acting on A, since we don't have vertical motion, okay? Since we don't have vertical motion, so resolving forces vertically, the R here, that is the normal reaction on A. So I can even call it RA. Then plus this side, 6 sine of 20, 6 sine of 20 degrees. Then this one is equal to this 2g going down. Then plus this t sine of what? 15. You see that? So our RA here is going to be equal to, first of all, this is 20. Then plus t sine 15. So our t is, if we can check back, t is this one here, okay? 0.6 out of cos of 15. So this is 0.6. then out of the cosine of 15 degrees, okay, that is the t, then times the sine of 15 degrees, then take this one this side, it will be a minus 6, then sine of 20, okay. That means our RA is going to be simplified as 20, then sine over cosine, we know that that is a tan, so I can say plus 0.6, then tan of 15 degrees, then minus 6, the sine of 20. So you can put this one in decimals, but me, I'm going to leave it here as exact, okay. Then since the movement is this side, okay, then we are going to have F, we are going to use F is equal to MA. So this is the force that takes the particle forward, okay. So we shall have 6, then the cosine of 20 degrees minus the opposing forces are these two here. So we have mu R, then minus T cosine of 15. But this T cosine of 15, if we check backwards here, it is this one 0.5 times 1.2. It is 0.5 times 1.2. Okay, let me put from part A. Is that clear? So minus this, I've subtracted these two forces from this one here, then it's equal to MA, and then M is 2. The acceleration from here is 1.2. The mass of A is 2, not so? So we shall put 1.2. Okay, now let's proceed. What are we going to have here? We are supposed to make mu the subject of the formula. So we have 6, then the cosine of 20, then this one is a 0.6, not so? So minus a 0.6, then bring this one this side, it will be minus 2.4, then this one will be equal to mu R. So meaning our mu is going to be this 6 cosine of 20 degrees, then minus, this will be a 3. Then we divide by the mu. So what are we then going to have? Mu shall be equal to 6 cosine of 20 degrees, then minus 3. Then we divide by this whole thing here, which is 20, then plus the 0.6. Let me repeat this, plus 0.6, then tan of 15 degrees, then minus 6, then sine of 20 degrees. Now we put this one in the calculator and we write our answer to 3 significant figures. So what will be our mu? 6, then cosine of 20, minus 3, then down here we are having 20 plus 0.6, then tan of 15, then minus 6 sine of 20. Then this one gives us 0.146, 0.146 to 3 significant figures, and that is that.